Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at organic chemistry, right? Yes, a very interesting topic now that we find in grade 12. And it is a very rich topic, okay? It is content rich, okay? Yes, it is a very content rich topic. So, what we are going to do, we are going to try to break down this rich content topic or chapter into now smaller digestible lessons. Okay, now it is divided into three parts. Okay, three sections rather. It is nomenclature, the first one that we're going to be dealing with for the next couple of videos. Then the other part, it is now physical properties, where we'll be dealing about boiling point as well as melting point, vapor pressure, and all of that. Then the third one, it is now organic reactions. Okay, so without wasting any further time, let's now see what exactly are we going to be dealing with on nomenclature. Okay, so on nomenclature, we'll be dealing with now naming. Okay, naming and structures. Okay, naming and structures. Okay, this will be our main focus on this particular intro of. Okay, yes. Now, it is very important of us now to be in a position of saying, okay, we're going to be looking at naming and all structures, but what exactly will we be naming thereof? Okay, so now we'll be naming different compounds. Okay, we have, I think, nine compounds that, or organic compounds that we need to name again. Yes, so without wasting any further time, now this is organic molecule, okay? I'll start by saying now this is organic molecule. Hence, you call it organic chemistry. Organic molecule. Now, what exactly is an organic molecule? We say now an organic molecule, it is a molecule that consists of carbon atom. Okay, a molecule that consists of carbon atoms. Okay, if that molecule does not consist of carbon atom, it is now, we refer to it as what? Inorganic molecule. For an example, if I have H2O, this is an inorganic molecule. Why? Because it does not have H2O. But if I have methane like this, it is what? It is an organic molecule. Okay, yes. Now, there are very important definitions that we need to be in a position of defining right now. Okay, the first one that you need to know, it is what we refer to as homologous series. Homologous series. Okay, a homologous series, I refer to it as a name. Okay, one thing I have to tell you is that the molecules that we'll be dealing with now, the organic molecules that we'll be dealing with, they have name as well as a surname. Okay, now the name is what I refer to as a homologous series. So a homologous series, we define it as a what? A series of compounds, a series of organic compounds. Okay, that can be described by the same general formula. Now, or general formula. Now, a homologous series, it is now a name of a particular series of organic compounds, meaning now, as we are dealing with what here? As we are dealing with organic compounds here, we will be saying, okay, we categorize these elements or these compound under these names. Okay, and now their name, let's say for particular case, their name will be alkane. Okay, these will be alkanes. Okay, that's how we see them. But now their surname will be what we refer to as a functional group that I'll define right now. Okay, their name, it is homologous series. A homologous series is their name. Let's say for an example, their name, it is alkane. Okay, what is their synonym? Which is their synonym? It is a functional group. A functional group is their synonym. Remember, synonym it is something that makes you unique. Okay, we have what you call a functional group. All the homologous series here, all the homologous series here have the same functional group. If you fall under the same homologous series, it means now your functional group will be the same. Okay, this will all make sense as we do examples now. Okay, yes. So a functional group, we say it is a bond, a bond. Okay, sorry, or an atom, or an atom, or a group or a group of atoms that determines now the physical and chemical properties of a group of organic compound. Group of organic compound. Now, let me repeat this. I'm saying a homologous series, it is, let's say you and your family, you have a family, okay? You have a family whereby we call you by whatever that family is. Let's say the Smith family, okay? Yes. But now each and every member of that family will have a unique functional group. Meaning, I mean, if you are all of, let me say, if you're all of the same house, okay, you'll have the same unique thing that we can categorize you from your neighbors, right? So now, hence, we say a homologous series, it is a series in which you are classified under. You are classified under, let's say, the same house, okay? House number 313, okay? Now, what's the functional group? The functional group is that all of you, your surnames are Smith. Okay, homologous series, it is the house that you belong to or the name of that house you belong to. Okay, then the functional group, it is what makes you special in that family. Okay, that can differ from other families. Okay, yes, this will make sense as we move on. For now, I just want you to know the definition. Now, the functional group, we say it is a bond or an atom or a group of atoms that determines the physical and chemical properties of a group of organic compounds. Now, when it determines the physical and chemical properties, it tells you now what kind of intermolecular forces that you have as a family, the strength that you have as a family as compared to the other families. Remember, each and every family has its unique strength, okay, compared to the neighbor's strength, okay? Yes. So that's the other definition that you need to know. Okay. Then we have what we call a general formula. You don't need to know how to define this. Okay. General formula for your formula. You need to define this. You need to know how to define this. You also need to know how to define this. You also need, let me do this and write it in a red color. Organic compound. Organic compound or organic molecule is still the same, okay? Now, what is that? Okay, this one you also need to know how to define it, okay? Yes. Now, the one that I'm going to do, a general formula now, it is a type of empirical formula that represents the compound of any member in entire. Let me not write it because it's not necessary for you to define it, okay? So I'll just show you how we write a general formula, okay? Then we also have types of structure, okay? Types of structures. Let me come here and say now we have types of structures. Okay, types of structures. Okay, now the first structure that we have, it is what we refer to as now a structural formula. Okay, this one will indicate all the bonds between the atoms. Let me make an example. A structural formula, it is represented maybe like something like this. This is what we refer to as a structural formula. Okay, this is what we refer to as a structural formula. The second one that we have, it is a condensed formula. Condensed, condensed. My English is running away. Condensed formula. Okay. Now the condensed formula does not show the bond and lines. Okay. Can you see this one shows the bond? Okay, here. It includes all the bonds between atoms. This one, this one, this one. But now on this one, we do not include the bonds or the lines like that. So meaning we'll just say it is C. C, it is surrounded by how many atoms? It is surrounded by 3H atoms. So we're going to say surrounded by 3H atoms. Can you see I did not include any lines? Then I'm going to say this C, the second C, it is surrounded by how many H atoms? It is surrounded by those H atoms. This is what you mean when you talk about a condensed. It is condensed. It does not show the what? The bonds thereof. Okay. Whereas a structural formula shows the what? The bonds. Okay. Then the last one, it is what we refer to as a molecular formula. This one you should be familiar with. Remember, we have molecular formula, empirical formula, okay? A molecular formula tells you the type of atoms and the correct number of each molecule, meaning it is, okay, the molecular formula, we're going to say we have two H two carbons. So it's gonna be say, okay, I have two carbons. Then I have H. How many H do I have? 3 plus 3, I have 6 H. This is what we refer to as a molecular formula. Okay. Most of the time you'll be dealing with now what we call a structural formula, but this does not mean you should neglect the what the condensed formula as well as the molecular formula thereof. Okay. Yes. Now, we have what we call IUPAC name. IUPAC naming. Okay. Now, IUPAC naming, it is just the International Union of Pure and Applied Chemistry, right? International Union of Pure and Applied Chemistry. So now, what does IUPAC naming help us is with IUPAC naming help us now to be in a position of identifying the what we call the prefix, okay, what we refer to as the suffix. Okay, let me do this, the prefix as well as the suffix. Sorry. Now, on the prefix will tell you, remember the prefix is the leading, okay, is the leading, it is the one that comes first. So it's going to tell you the number of carbons in the longest chain. Okay, then let me write prefix here. So the suffix here, I'm gonna need that space. So a suffix, okay, let me take this, uh, move it here. So I want you to see a prefix is gonna be something. Let's say if, then something, okay? It's gonna tell you the number of carbons. Now, how do we know the number of carbons? How can we see them? Now, we say the number of carbons, we see them like this. Let me see if this color is perfect. Okay. If I have one, it is meth. If I have two carbons, I'm talking about the number of carbons here. If I have two carbons, we call eth. Okay. If I have three, I call it prop. Okay. If I have four, I call it but. . Okay, butane. Well, let me see. Butane, butane, Let me see. Sorry, butane, butanone, butane. Okay, just call it but for now. 5, you call it. Remember, this is the same as geometry, man. The shapes. 5, you call it pent. 6, you call it hex. 7, you call it hepta. Now we limited to 8 that we call oct. Okay. Now you won't just say myth, blah, something. Okay. Now you know how to use these words very, very correctly. They're off. Okay. Yes. Now another thing, the suffix, it is now the ending. Okay. The ending. Now the ending here, the suffix will be the ending of the functional group. Okay. Functional group. Okay. Let me do this. The ending, let's say, A, for an example, okay? It is something, can you see? It is something, let me do this, something, then A, okay? Whereas here we said it is if, then something, okay? So if I were to mix this prefix and suffix, I have ethane. Can you see? I have ethane if I were to mix those words together. So that is the purpose of us being in a position now of naming. Okay, the suffix will tell you about uh the functional group. Okay, this kind of homologous series, functional group, this kind of homologous series has now a functional group that is unique to them, and it has an ending of "-ane". For alcohol, it has an ending of "-ol". For a ketone, it has an ending of "-one". Something like that. Can you see? So these are the things that we need to be in a position of being able to take. We have to be aware of, rather. Okay. Yes. Now let's start with, now we are going to interesting stuff now. Okay, now we are starting the naming and all of that now. Okay, but where does it start? We have what we refer to as hydrocarbons. Okay, hydrocarbons. What are hydrocarbons? Okay, hydrocarbons per definition we say are now organic. Can you see organic compounds or molecules? But from the name, you can see hydro for hydrogen, then carbons for carbons. Okay, so it is organic compounds that consist of only of only hydrogen, hydro, hydrogen, and carbon atoms. Meaning we have only C and H and H and H and H, like that, like that. But the minute I say O, H, like this is no longer a hydrocarbon. Why? Because now it does not consist of only carbon and hydrogen. It has now what? Oxygen. Okay. Now, prior knowledge is that when you're naming, okay, when you're naming, or rather, let me just put it here: the bonds, under bonds. Okay, under bonds, carbon can accept 4 bonds, like that. Okay, hydrogen can accept only 1 bond. Okay, remember why? Because remember the valence electrons from grade 11. Okay, so we are saying carbon has 4 spaces, okay, for them to bond. Remember when we draw the Lewis structure, we are saying these are lone pairs. Okay, then these are bonded pairs. Okay, so we need to fill up these lone pairs here. Okay, yes. So how many bonds can we have? 4. 1, 2, 3, 3, 4. Okay. Then now we say for hydrogen, For hydrogen, we have one like that. So we need only one. So it needs only one. Then for oxygen can allow two bonds. Okay, very very important knowledge from grade 11 thereof. Now let's look at the first one that you're gonna study against. Not against. We're gonna study under hydrocarbons. We refer to it as alkane. The first one, alkane. Okay. The first one, it is an alkane. Okay. So now, an alkane now, it is an organic compound containing only CH atom and CC single bond. And alkane, it is a homologous series. Okay. This is homologous series. Homologous series. So it is the house that they fall under. They fall under the house called alkane. Okay. So now, what is the functional group of alkane? Okay. What is the functional group of alkane? Functional group under alkane. Number one, functional group. I said now the functional group, it is what makes now alkane special from other carbons, from other organic compounds that we're going to be dealing with, okay? Or that we're going to study as we move on. Now, we are saying alkane specializes by having what? Single bonds between what? Carbon atoms, like that. Let me use a black color. It's specialized by having now single bond between what? Carbon atoms. Carbon atoms, we have a what? A single bond. Then the rest will be like that. Okay. So remember, carbon can only bond to four, which is 1, 2, 3, 4. Also, this carbon, it is 1, 2, 3. Remember this, you also count it as 4. Okay. This what makes now a alkane special. It is what? The single bond between the carbon atoms. Okay. And it is a hydrocarbon. Why? Because it consists of only a carbon as well as hydrogen. But now when they say draw the structural formula of a functional group, you show what is special. You only show what makes a functional this hydrocarbon special. It is what? It is this the C bonded with the other C by a single bond. Okay, then the other lines to show, okay, there are some things that we need to fill. But since when we are not drawing the structural formula, a complete structural formula, we're gonna leave the as blank as it is, like this. Okay, so this is what makes alkanes now, which is a homologous series special. A functional group, remember, it is something that makes your family so special. Okay. Now, what is the general formula for this one? A general formula, it is a formula in which now you will be able to now to say, okay, I can count now. Actually, a general formula is a type of empirical formula that represents the compound or any member in the homologous series. So now a homologous series, so all the alkanes, let me number this like this. It is number one. All the alkanes will have the same general formula. Why? Because they are of the same what? They are of the same family. You can take general formula as a gene or a DNA gene or whatever. Okay. So now the general formula thereof for this one will be CnH2n plus 2. What do we mean? We mean that, okay, if I have C and N represent any number of carbons, so it tells me if I have 5 carbons like that, okay, I have to do what? I have to say H, then whatever that value N here, I have to multiply it by 2 so that it gives me 10. Then I have to add it to 2. Therefore, if I have C5H12, like this. So it tells me, oh, okay, the type of empirical formula that I'll be dealing with thereof, it is something like that. Let's see. Is that the honest truth? Let's see. Let's assume that here we had, okay, let me draw this and say now we have hydrogen. This is a structural formula, okay? This is the structural formula of a functional group. We show only what's special, but here it is there like that. You as of yet, you don't know how to name this, okay? As of yet, you don't know how to name this, but you will, because I will also be doing the naming, okay? So now I'm gonna say, okay, C2, how many carbons do I have? I have 2 carbons. How many hydrogens do I have? I have 1, 2, 3, 4, 5, 6. 6. Does it follow the pattern that says, okay, if I have Cn, H2n plus 2, let's see. If n is 2, if n is 2 here, I'm gonna say C2H. Now, this n, I said this n is 2, right? So I have to say 2 multiplied by 2, it should give me 4. 4 plus 2, therefore it is C2H6. Can you see now? Therefore, it means this one, it is correct. Sorry. I mean, this one, it is that one. Can you see that? So it means it follows the very same gene pattern, okay? The pattern of the family. So it means this is classified under what? Alkane. You can also see it as what? Under what? Alkane, due to what? To the general formula. You'll see, as we go to alkene and alkyne, we are going to subtract 2. Okay, as we move from alkane to alkene to alkyne, we're going to subtract these 2. Okay, now let's have a suffix for this one. Okay, a suffix. A suffix for this one, we say now a suffix for this one, it is the ending. Which is the ending? The ending, it is, can you see alkane? Alkane. So it means each and every ending of this compound that you're going to name under alkane should end with ane. Remember, it should be something, then it ends with ane. Okay, now let's look at an example of naming. Now let's naming alkanes. Let's start with the basic one. Okay, let us have what? Now let us have H, the one that you've been dealing with all this time. Okay. Now, when I name this, remember I start with the prefix and then the what? The suffix. Now, the prefix tells me about remember what does the prefix tells me? The prefix tells me the number of carbons in the longest chain. The longest chain. The longest chain here, it is mad. Can you see the longest chain? It is 1 and 2. The number of carbons that I have, it is 2. And I know 2 carbons, according to my prefix, it is what? It is if. It is if. This is my prefix. If. Okay? But now, what is the ending? What is the ending or the suffix of this? It is what? Ane. Can you see that? So it means when I name this, I'm going to say it is if the prefix, then ane. So this is the name of that compound, ethane. Ethane. Like that. Why? It tells me, oh, okay, me being in a position of reading this name, if I read this name now, I should be in a position of knowing to do what? To draw the structure. To draw the what? The structure thereof now. To draw the structure. Why? Because I'll say, okay, what is this? If it means now I'll have what? 2 carbons, okay? But now it falls under what? Oh, let me say 2 carbons, okay? It falls under what? Ane, and this is a functional homologous series of alkane, okay? And the functional group of alkane, I know it is what? It specializes with a single bond between carbon and carbon, okay? Therefore, I'll be in a position of saying, okay, therefore, I fill up the other bonds like that. Like that. So can you see this structure is the same as that one? Yes. Let's have now another name. Let's have now another name. Let's say now we are in a position of saying have H, C, 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 H, H like that, 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 and H like that. Now, let us be in a position of naming this. The longest chain, the number of carbons I have, it is 1, 2, 3. Okay? 1, 2, 1, 2, 3. Okay? Now, what about, okay, the first thing that I do before I name, I do what? Let me take this. Uh, okay, okay. I move it a little bit here. Okay, the longest chain here it is 1, 2, 3, and I know a prefix for 3 it is prop. So I'm gonna have prop. Okay, but now this is under what? Can you see? I have only single bonds between the carbons, and that falls under what? That falls under alkane. So the functional group here it is single bond. Okay, carbon single bond. So I'm gonna have propane. Since well they all fall under alkane, it means the ending I'll see it by ane. So if I have something ane, I know automatically this is under what? This is under alkane. Okay. Let's now get a little bit interesting. Let us now get a little bit interesting now. Let us get a little bit interesting now. You just have to make sure that the carbon has all the 4 bonds it needs. Okay. Now, it's very easy to name an alkene, trust me. The naming gets harder as we move down now to alkene, alkyne, alcohol, aldehyde, as well as all of that. Okay. So now the longest chain here, we say, okay, let's see. Longest chain, it is the number of carbons that give us the longest chain. 1, 2, 3, 4. Then can you see it continues like that going there? It is 5. Okay. So now, can you see the longest chain? I can see here it is this one. Okay. Yes. So by doing that is me saying, okay, the longest chain here, it is what? It is 1, 2, 3, 4, 5, which is what? Remember, 5, it is what? 5, it is, this is propent. Pent. But now this is under which homologous series? Alkane, okay? And remember the alkane, the suffix for alkane, it is what? It is pentane. Suffix for alkane, it is ane. So I'm gonna have what? Pentane. Now, let me just give you a moment and try this one for yourself, okay? Try this one for yourself. If I have now, now try this one for yourself. Try this one for yourself, okay? Yes, let's try to take this, all of this, and move it a little bit higher. Ish, while you're still trying there off. Remember the important part, it is the longest chain. Again, then now you'll do the functional group or whatever that makes these naming to be special. Cool. Now let's name. Let's see the longest chain. I say it is 1, 2, 3, 4. Okay. One might say, okay, why didn't you go up? It's fine. If I go up, can you see it is going to be 1, 2, 3, 4? Either way, the chain is the same. Okay. The chain is the same. Okay. If now the chain is the same, now we're going to say, okay, if the chain is the same, that's cool. Let us be in a position of saying, okay, but the question is, what will happen to this carbon here? The carbon that does not have anything, we refer to it as a branch. We refer to this as a branch. Okay, this is what we refer to as a branch. So now, what about a branch? Now, a branch, it is an alkyl group. alkyl group, meaning it will have a suffix of "-ile", meaning a branch has a suffix of "-ile", meaning if I have one, can you see I have only one branch? If I have carbon and all of these, I have one branch. So it means this one will be a what? If I were to name this one, will be a one means what? Meth. Then it has a suffix of what? Of "-ile". This is how we call branches. The branches has a suffix of "-ile", okay? Then the prefix will just be the number of carbons on that branch, okay? It is methyl. So when I name, I say, okay, the first thing first, I have the longest chain, which is 1, 2, 3, 4, which is what? My longest chain, it is 1, 2, 3, 4, which is what? Which is bute, okay? Longest chain, my prefix. My suffix will be what? My suffix will be a functional group, okay? Then I know this is under alkane, and alkane has a suffix of "-a", okay? But now I have a branch, okay? Now I have a branch, okay? That branch, it is a methyl branch, okay? Methyl branch. But I need to tell you, I need to tell the examiner, okay, this methyl branch, I saw it, or rather, as I was moving along with my longest chain, I saw a branch. You have to tell me on which carbon. Okay, you have to tell me I saw a branch on which carbon. So can you see on carbon number 1 there's no branch, on carbon number 2 there's no branch, but on carbon number 3, the one that joins to carbon number 3, it is a what? A branch. So it means I saw a branch. You'll say on carbon number 3 I saw a branch. You'll say hyphen branch. That branch, it is what? It is a methyl branch. Why? Because it has one carbon. Okay, so when I compute this, remember, okay, another thing, between a word and word, there's no hyphen, okay? There's no hyphen. But between a number and a word, they should be divided by a hyphen, or you prefer to call it a comma, okay? So the name of this compound, when we execute it very nicely, we're gonna say it is bute. Oh, sorry, we start with a branch, okay? When you start naming, you start with a branch. You're gonna say, okay, on carbon number 3, I met a what? A branch called methyl branch, okay? A methyl branch, and in that branch, I saw it on a longest chain called what? Bute, and it was under alkanes, therefore it will have an ending of "-ane", okay? So can you see this is similar? This is a butane, okay? But now it is no longer a normal butane. Why? Because now we have something that is special that we encountered during the journey. So what is that something special? It is a methyl group or a branch on carbon number 3. You'll say, okay, I met a 3, all right, I met a methyl group, okay, a methyl group or a branch of one carbon on carbon number 3. Hence, I'm saying 3-methyl butane. Okay, so this makes it easier for me to say, okay, from this word now, from this name you have given me, can I be in a position of throwing the structure off? Let me remove this. Can I be in a position of throwing the structure off? I'll say, okay, yes. Why? I start here, butane. I say, okay, I know butane, it is a what? An alkane. Why? It has 4, bute means 4, okay? 4 carbons. And I know I'm going to have single bonds. Why? Because it is butane. Remember, butane, it has singles. The functional group of butane, it is what? It is single bond between the carbons, okay? Then now, okay, I'm saying, okay, I have done this, okay? But now, I have something, okay? I made something. Can you see the longest chain? I can do it like this, or even if you were to do it like this, like that, you'd see, oh, okay, here this becomes a methyl methyl group. If I make my longest chain to become like this, the straight like this will be a methyl branch. But can you see the position of it, of that branch? It is on carbon number 1, still on carbon number 3, so it does not affect anything. Okay, so either way we take that one or this one as a branch. It depends on the numbering. Okay, provided that it is correct. Okay, hey, therefore I'm gonna say, okay, butane, here it is a piece of butane. Okay, but now I know I'm gonna need the bonds here. But now I'm not done. I'm told that on carbon number 3, on carbon number 3, I say, okay, let me start counting here. 1, 2, 3. What happens on carbon number 3? I met a methyl. I met a methyl. What is a methyl? A methyl, it is a branch that has what? 1 carbon. Oh, on carbon number 3, 4 here. On carbon number 3, I met a methyl, meaning I can say, oh, I have a branch thereof on carbon number 3. Okay, so, oh, a carbon, I have on carbon number 3. Can you see that on carbon number 3, I met a what? A methyl. A methyl, remember, it is a branch that has what? 1 carbon. So I'll be in a position of saying, oh, okay, therefore it means now, okay, I have this. Then is there anything left? No. Except for what? For just completing the hydrogens. Okay, so this is what it is, like that. Remember, just completing H is here. Okay, H here. Remember, if you miss one H, you are out. You have to count whether the carbon is bonded to 4 now. 1, 2, 3, 4. Can you see it has all the 4 bonds like that? Okay, you need to count like that. Okay, so can you see the structure that I've drawn here? It is the same as the structure that I have there, that I took the name from, whereas this is becomes a what? A branch. Can you see now I'm having, okay, I'm having the same structure here. So I'm teaching you how to name as well as to how to reverse that part. Okay, yes. But now, what if we have something like, okay, you now know how to name including a branch, right? Let me make a last example about this one. Let's say now you have H, C, H, H, C, H, C, H, 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 C, H, H, C. I can put a branch anywhere I want. H, 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 C, H, H, H. 2, 4, 2, 4, blah. Let me see. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Allow me to add another carbon here. Okay. Okay, let me do this. H, C, H. This is what an examiner does when they said, they just see, is it enough? No, it's not enough. Let me put more. Okay. But trust me, it's not difficult. What's the first thing you need to know? The first thing that you have to know, it is the longest chain. Okay. How do I find the longest chain? I'll say, okay, let me start counting from here. It is 1, 2, 3. I see a carbon. If I go there, it is 4. Okay. Is it the longest chain? No. Why? Because if I didn't go, remember, if you go like this, you cannot come here and say 5. It is not a straight chain. Okay. Remember, your straight chain can be like this, or it can be like this. The minute you start doing this, and going there, this is not the longest chain. Okay. So if I come here, I say, okay, it is 4. It is little. Let me come here and say this is 4. This is 5. That is 5. Okay. When I come here, it is 6. What if I came here? It was still gonna be 6. So either way, I go there up, or I continue with a straight line. Okay. So instead, I'll just continue with a straight line like that. Okay. Yes. Yes. Now, okay. Okay. What do I have there? What do I have there? I have the longest chain. That is what? The longest chain is 1, 2, 3, 4, 5, 6, which is what? Hex. Hex something. Okay. And I know this is under what? alkane. Why? Because they are single bonds only between the carbon-carbon atoms. So I'm gonna say I have an ending of ane. How interesting is that? But now, is there something that did not get a number? Yes. What is that? It is this. Also this. What do we call those? We call those branches. Okay, these are alkyl groups. These are alkyl groups. But now, okay, if this is an alkyl group, what about it? So I'm told that on carbon number, I'll start with the smallest one, with the smallest number. Okay, the one with the smallest number. Oh, okay. Now I want you to see something. Can you see now? I named from here to there. It is 1, 2, 3, 4, 5, 6, 6. But one thing I can do is I can also start from here and say it is 1, 2, 3, 4, 5, 6. Okay, yes. Can you see now? The longest chain is still hex and it is still under alkanes, right? Now, when I name the branches, I want to name them such that their numbers is low when I count. What do I mean? Okay, let's assume that we started with the red one. 1, 2, 3, 4, 5, 6, that is red. It was gonna give us, you're gonna say, okay, on carbon number 3, I met a methyl, okay, a methyl, as well as carbon number 5. Can you see when I use red, I met a what? A methyl. But since while they are both methyls, you're gonna say, oh, okay. It means now when I combine this, it's gonna be on carbon number 3, 5. I had what? Methyl. But how many methyls did I see? I have 2. So I'm gonna say it is dimethyl. Okay. I know the naming is gonna get tougher as it goes now. But now this is what we refer to as this one. So it tells me, oh, okay, on carbon number 3 and on carbon number 5, I have methyls. Okay, because why am I using di? It means now I have 2 of those methyl groups, but on different carbons like that. Okay, so it's gonna be 3.5 dimethyl. Okay, so this is when I use the red longest chain. But what if I use the blue longest chain, this one? It's gonna say, okay, on carbon number 1 and 2, can you see on carbon number 2, I have a methyl. Let me write it here. On carbon number 2, I have a methyl. And on carbon number 1, 2, 3, 4, I have a what? I also have a methyl. So when I add this, it's gonna be, do you agree with me? It's gonna be what? 2, or comma 4. What? How many methyl do I have? I have this one and this one. Is gonna be dimethyl. Like that. Now, the question is, okay, both of these I have. So I cannot have both of these. The question is, which one between this and this is correct? Now, the one that has the least number when I add this, the one that has the least number is the one that is correct. Why? Because as we name, we want to name from where we get the smallest possible number. What do we mean? When I say 2 plus 4, it gives me how much? 6. 3 plus 5, it gives me how much? 8. So it means I will use which one? This one. Why? Because it gives me the smallest possible number. This one gives me the greatest possible number. So I do not want this. So instead of, I want to use this. So it means now I will use the longest chain starting from where? Starting from the blue side, like that. Okay. It's also important that I'm doing these examples because now it is very, very important to be in a position of understanding. So it means now when I compute this name into one single name, I'm going to say it is what? Remember, this is the last part, hexane. I know I'm going to end with hexane. But now, what is it that is supposed to come here? Remember, the hex tells you about the number of carbons, then ane tells you it is under which functional group, which is under alkane, single bond, okay? So now I have to come and complete this and say, okay, it is 2.4 dimethyl hexane, and come and say, okay, this is 2.4 di. Between a number and a number, you need a comma like that, or a dot, I don't know, then a methyl. So and remember, between a number and the name or a letter, it is a hyphen. So it's going to be 2.4 what? dimethyl. Do I need a hyphen here after dimethyl? No, because why? It is a letter and a letter. Between a letter and a letter, there is nothing. They just combine like that. So this is the correct name. Oh, what happened? This is the correct name. 2.4 dimethylhexane. Now the question is, can I draw a structure from this one? Yes. Why? Because I'm gonna come here. First, I start with the longest chain and the functional group. It is hexane. I'm gonna say, okay, 1, 2, 3, 4, 5, 6. When you draw it, it might be different from what you see. But now what's important is the numbering, okay? 1, 2, 3, 4, 5, 6, the longest chain. And they are all what? Hexane, okay? I can say, I mean, they are all alkane. So they have single bond, single bond, single bond, single bond, sub. Then I come here, I say on carbon number 2 and carbon number 4. So if I start counting, I'm going to start counting from here in an exam, okay? I'm in an exam. I'm going to start counting from there, okay? I'm going to start counting from there. If I count from there, I'll have on carbon number 2 and carbon number 4, I have a methyl group. Oh, on carbon number 2, I have a methyl group. So I'll have this. Oh, and carbon number 1, number 4. Oh, oh, then what? I can complete the rest and say, okay, the rest are hydrogen, 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 hydrogen. Make sure you not miss any hydrogen, hydrogen, hydrogen. Oh, so is this the same as that one? No. Yes. Which one is the correct answer? It is yes. Now, remember, when you draw a structure, you can draw it in different ways. But as long as you're gonna name it, what's important is that when the structure that you have drawn, we have to name it. It should be the same. Okay, remember there are two methods. There are many methods to calculate something, but what's important is the final answer. What do you mean? It is you can draw the structure in different ways, but I want you to be in a position of when I take the structure that you have drawn and the structure that a particular person has drawn, they are different because it is a structure. A structure can be different, but now when I get the name of those two different structures that you have drawn, it should give me the same answer, okay, or the same name. Let's see, is it true? Let's see. The longest chain, it is hexane. I'm gonna say, okay, the longest chain, it is hexane. What do I see on carbon number 2? Okay, on carbon number 2, I see a branch, and on carbon number 4, I see a branch. And all those branch are methyls. So I'm going to say, oh, on carbon number 2 and carbon number 4, I have methyl branch. So I call them dimethyl. So can you see the name here and the name here is the same? So now it means now the structures does not matter whether you have started here. When you draw, it does not matter whether you start here to there. But when you count, when you name, you are given a structure, you have to be take a full accountability of that. Okay, yes. That is exactly what I meant thereof. That is exactly what I meant. Okay, yes. Now, important. NB. When naming an alkane, you prioritize a, an alkyl group or a branch. An alkyl group is the same as branch. What do I mean? I mean that when I count, I'm gonna count from the what? From the carbon with the I'm gonna start counting from what? From where I get the carbon. I mean the branch, the list number. Okay, here I see the naming is wrong. Okay, I just realized here the naming is wrong. What do I mean? Check. If I use this counting here, 1, 2, 3, 4. Which one gives the branch the lowest number between the red and the blue? Which one gives the branch the lowest number? Can you see that 2, it is the smallest? So instead of saying I saw it on carbon number 3, I'll rather say, okay, it means I want to start my chain on that side. Why? Because it gives my carbon my branch lowest number. So it means I come here and say, okay, instead of 3, this is gonna be dimethyl. Okay, remember I want to give a branch the lowest number. Okay. Similarly, here there was no branch. Here there was no branch, so you were numbering failure because there was no branch only on alkanes. But now on here we said, okay, I want to give a what? My branch is the lowest number. If I start here, it's gonna be 1, 2. Why is this 3 so far away? 4 here. Why did I here? Did I move this one by mistake? Maybe this is 3 here, 2 here, 1 here to show it is on carbon. Okay, this is when I start counting from there to there. Can you see I get on carbon number 2 and carbon number 4, and I know that 2 plus 4 gives me 6. Let's see when I use red. I've already done this, but I'll repeat for the purpose of clarity. It is 1, 2, 3, 4, 5, 6. Can you see now when I start counting from here going there, I have what? A branch on carbon number 3 plus a branch on carbon number 5. Then it gives me what? 8. Between 6 and 8, which one is the smallest? It is 6. So it means I will take the counting where it gives down the smallest possible number, which is what? It is the blue one in this case. So I'll say, okay, let me remove this naming. No, sorry, this numbering. I use this one instead because it gives me 2 and 4, the smallest possible number thereof. So that is exactly that. That is exactly that. Now let's move on to the second type of alg. Now that I've explained that, moving forward, it won't be that necessarily difficult for us to name or draw or what, okay? Or another thing that I want you to take note of, the what's this? The condensed formula. The condensed formula here is going to be, I have what? C, then how many H surround C? It is 3. Then I have another C. How many H surround that 3? That H, it is 3, okay? Then on this one, I'm gonna say I have the first C. This one again, it is surrounded by how many hydrogen? 1, 2, 3. Then I have the second C. It is surrounded by how many carbons? 2. Sorry, surrounded by how many hydrogens? 2. Then I have another C surrounded by how many? 3 hydrogens. So this is what we refer to as a condensed structural formula. Then for this one, I have the first C surrounded by how many carbons? 3. I have the second C surrounded by 2 carbons here, surrounded by 2 hydrogens, sorry. I have another C surrounded by 2 carbons again. I have this C here. Can you see this C? C surrounded by H2. Then as go up, I have what? We're not gonna guy. Hey, okay. Okay, let me do that. I quickly do that. Okay, I'm still on carbon number 1, 2, 3, 4. This one, it is surrounded by 2 hydrogens. Can you see? It is this hydrogen and this hydrogen only. Here, it is not a hydrogen, it is a carbon. Okay, then I'm going to say C. How many hydrogens? 1, 2, 3. H3, like that. Like that. Okay. Then I can do these ones also. These ones are interesting. Why? We check. I'm going to say it is C, then it is H3. Here, the second one I'm going to say is C and H2. On this one, I'm going to say it is CH. CH. But can you see here I have a branch? If I have a branch, I'm going to say CH3, like that. I'm going to enclose that as a CH3. Or rather, I'm going to say, okay, here it is CH, but now I can have a what? On that carbon, I also have a what? A CH3 to show that it is a branch. Remember I said a condensed does not show bond, okay? But now when you want to show that there is a branch, you're going to say, okay, on this carbon number 1, 2, 3, there is a what? A branch. Or rather, instead of doing that, you're going to say, okay, it is a CH and a what? I have a what? A CH3. When you put it inside the bracket, say I see, okay, on carbon number 3, I have an H as well as a what? As a CH3, which is a branch. Then I have a what? I have a C and H3. I want to believe you are following. Okay. Then let's name this one. Let's look at this one. The condensed is going to be 1, 2, 3, 4, 5. Oh, sorry. CH3. Okay. The first one surrounded by 3 hydrogen. Second one surrounded by 2. The third one, can you see the third one? It has H, but now it has a what? A branch. So I'm going to say, okay, open a bracket, CH3. Then the fourth one here, I'm gonna say, I know I started counting there, but when I name it's fine. I can also come from here to there, it's fine. That way it won't make any difference. CH, I'm going to carbon number 1, 2, 3. 1, 2, 3. Here I saw a branch, then I come to this carbon, then it is surrounded by 2. Then I come to this carbon here. Let me move my name there a little bit like that. I was here, right? Then I come to on this one. I say, okay, it is CH, but on that H, on that carbon, I also have a what? A branch. It's gonna be CH3. Okay, then the last one CH3. So this is what you mean by the condensed structural formula thereof. Okay, yes. Now let's move to the second type of hydrocarbon. Remember, we saw alkane, right? Now, as we move on, we say now it is no longer alkane, but now it is what? Alkene. Kene, okay? Alkene, okay? Now, what this, remember, this is a homologous series. So this will be different from that one because now it is the different homologous series. Homologous series. So this is a homologous series of alkenes, okay? Now, when I want to see its functional group, unlike alkane, remember on alkane, I said it has single bond between carbon atoms, okay? But this one will have what? Double bond between carbon atoms. It will have double bond between carbon atoms. What do I mean? Can you see that? Can you see that? Okay, let me say between carbon atoms, it will have what? C double bond, CC double bond. This is the functional group, okay? Now, remember, carbon can have 4 bonds. So this is 1, 2, then I need 4. You can say this is 4, this is 5. Okay, or you can also put it here 4 or 5, or you can also put it here 5, 4. Oh, you don't need 5. So put it like this, or like this, like that. Or you can also say it is CC, like this, like that, like this, like that. It's fine. Or you can say it is C double bond C, like that, like that, like that, like that. However, okay. But the one that we prefer to use it is this one. So whichever it is correct, so that you know, Luena, whichever that you use thereof, it is correct. Okay. So don't be discouraged when it does not is not the same as maybe the one that your teacher does. Is the same. What's important is now the bonds are how many bonds we have. Can you see now we have 1, 2, 3, 4 bonds on the first carbon. On the second carbon, it is 1, 2, 3, 4. So it means now it is complete. This is what we refer to as a functional group. This is the structure of a functional group. What does the structure of a functional group do to us? It tells us, it makes us to know what kind of homologous series we are dealing with. What do I mean? Can you see? This is what makes the alkene special. Remember, I said the functional group makes that particular family to be special. What is special about this? It has double bond. About that one, what was special? It had single bond. Oh, so it means alkane has a single bond and it differs from alkene because alkene has double bond. Yes, that's the honest truth thereof. Okay. Then now I go to my general formula. Do not confuse the general formula as well as a empirical formula or whatever formulas. The general formula of this one will be what? Will be CnH2n. Why? Because remember I said when you move from alkane to alkene, you subtract 2 hydrogens. Okay? You subtract 2 hydrogens. What do I mean? Can you see here we had how many hydrogens? 1, 2, 3. 1, 2, 3. Which gives us 6. But here, how many hydrogens we have? 1, 2, 1, 2, which gives us 4. So can you see, instead of 6 carbons, we have now 4. So it means on the number of hydrogens here, we subtracted how much? 2. Okay? What do I mean by that? If I have, how many carbons I have here? I have 2. Therefore, I have how many hydrogens? 4. So it's going to be 2 multiplied by this n, which is 4. Is it true? Let me draw that structure. So for alkene, for whatever carbon here, I'll have double of that. Oh, can it? So remember, this is an alkene, it will have double bond. I'll say H, 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 H. If they ask you for a structure of a functional group, you do not include H. You show only the special thing, okay? Then when I count here, I'm going to say I have how many carbons? I have 2. Then I count how many hydrogens? 1, 2, 3, 4. 4. Does it follow the formula that says CnH2n? Yes. Why? Because if I have 2 n's, I have 1. If I have n is 2, therefore how many H should I have here? I should have 4 because it should be 2 multiplied by that. So it is indeed. It is indeed. Okay? Yes. Now, that is the general formula there of CnH2a. Okay? Now, we look at what? The suffix. The suffix. Now, what did we say it is the suffix of this one? We said the suffix of alkane, it is ane. On this one, can you guess the suffix? Can you guess the suffix? I think you should be guessing that by saying, oh, if that one ended with ane and the suffix was ane, it means this one should be in. Oh, so this is how these things works. Indeed, true. This is how these things work now. Okay, so the ending or the suffix or the for alkene compounds will now end with what? In. Whereas we know the prefix is just the number of carbons, whether meth, eth, prop, but, hept, whatever. Okay. Now, okay. Can I be in a position of naming the alkenes now? Naming the alkenes. Yes, indeed. Why not? Okay. Why not? Why can't I not name them? Because now I can see now the structure. Sorry about that. I was drinking water. That is followed thereof. Okay. So I'll say, okay, how about we name alkenes? Unlike this one, what happened today? Unlike alkanes, where we said, okay, we're gonna prioritize a branch. In this case, we won't prioritize a branch. Remember on this one, we said you prioritize a what? A branch. These are the notes that you should make for yourself, okay? When we name a what? A what? What's this what? In alkane, we prioritize a branch. But when naming, sorry, when naming an alkane, I prioritize, let me write it here. Prioritize the double bond. What is that? You prioritize the CC double bond. You start counting from where you give this double bond a smallest number. This IUPAC naming is going to be a lot for me. Trust me, you'll get used to it, okay? It's fine. For now, it's fine just to say it is a lot and I understand you. How do you prioritize a double bond now? I'm going to say, okay, if I draw my structure like this, if I draw my structure like this, remember why can I not put hydrogen here? Can check. When I put hydrogen, it's gonna be 1, 2, 3, 4, 5, and that is incorrect. Remember, a carbon can only a bond 4 to a maximum of 4. Okay. So now I said, okay, I prioritize a what? A double bond. Oh, okay. So when I prioritize a double bond is closest to this side or this side. I see to that side, this side. So I'm gonna start counting and say it is 1, 2. Okay, so this double bond it is between carbon number 1 and 2. So I'll say, okay, this double bond is on carbon number 1 instead of 2. Okay, yes, you take the one with the least number. Okay, then when I name, I still follow the same approach and say, okay, the longest chain here it is 1, 2, 3. 1, 2, 3 it is prop. Okay, the suffix here or the ending here it is what? It is in. The ending here it is something in. Oh. Okay. Then now I check, oh, okay, I know it is propene, but I cannot just say it is propene. Why? I should say, oh, okay, I saw something that I'm not familiar with, which is a double bond. And that double bond, I saw it on carbon number man. On carbon number one, because why? Because I started with carbon number one and did the double bond and went to carbon number two. I won't say I saw a double bond on carbon number two, because between two and one, the smallest it is one. So I'll say, oh, on carbon number one, I saw a double bond, and that double bond it is called what? In. So I'll say, okay, instead of saying it is propene, I'll say it is prop. Then on carbon number one, I saw a what? An in. I saw a double bond, and a double bond it is referred to as what? As in. So I'll say, oh, the longest chain it is prop, which means three. But on carbon number one, I saw a what? An in. Oh, indeed. So it means when I execute this name, I'll say it is what? Prop. Remember, between a letters and a number, I have a what? A hyphen. Okay? I'll say, oh, let me execute a name for this one. How can I do that? How can I do that? I'm going to say, okay, the longest chain now it is prop. The longest chain here it is, what's happening? Okay, my pen is not working. Okay. Okay, I'm having a problem here. Okay, let me do this and try to see what's wrong actually. Okay. Okay, my pen has stopped working. I don't know why. Let me disconnect this and connect it again. Okay, I'm having a problem with my pen. I'm not sure if the battery has died or what. Delete. Okay. I don't know what now. Okay. What's happening? Let me do this. Okay, let me pause the video for a little bit. Okay, I have fixed the pen problem thereof. I was starting to get scared now because, hey, I'm in the middle of recording a very, very interesting topic thereof. Okay, now I repeat, when you name, you start by naming from where you find your special thing. What is special? Your functional group. What is your functional group? Your double bond, where the on the lowest part. Okay, now, here, what is the minimum number you can give the double bond? It is one. So I'm going to say, okay, the longest chain it is three. Okay, I removed. The longest chain it is three, okay, which is prop. But now, within that prop, on carbon number one, I saw something special, which is what? Which is in. So can you see? Remember, even here, we said the longest chain it is four. I'm going to use this. The longest chain is four. But as I was moving along with my longest chain here, I saw a what? I saw something special. What's that something special? That something special, it is on carbon number two, and it is what? It is a methyl group. So I said, okay, on two carbon number two, I made a methyl group. On which? On what? On a longest chain. Hence, I came about with this name. Okay? Hence, I came about that name there. Yeah, there is a bond that's missing. But here, since well, this is an ending, this functional group, it is an ending. I will not say it is one in a proper, in a prop. No, I won't say that. Instead, I'll say, okay, the longest chain it is prop, meaning I'll say it is prop, what? On carbon number one, I saw a what? An in, like that. Prop one in. This is the correct naming. Prop one in. Why? Because if I'm in my position of wanting to draw, I'll say, okay, the longest chain it is prop. I'll just say one, two, three. Okay? I don't know as of yet. One, two, three. I don't know whether it is in or alkane. Okay? Hence, I'm just writing three. prop for 3 carbons. Then I say, okay, here on carbon number 1, I'll start counting from here. It's fine. I'll say this is my number 1, number 2, number 3. Okay. What do I see on carbon number 1? In. What is an in? An in is a carbon double bond. I'll say, oh, here I have a double bond. Therefore, I'm done. Therefore, it means I can complete the rest by saying, okay, therefore means this one, it is hydrogen here, hydrogen here, hydrogen here, hydrogen here, and maybe hydrogen there. Why? Can I add a hydrogen here? No. Why? Because the maximum bond, it is 1, 2, 3, 4, it is complete. Now, can you see now, this and this are the same, but now the change is that my functional group, I put it on the carbon here, on this carbon on this other side. Oh, but on the structure I was given on this carbon on the other side. Does it affect my results? No. Why? Because can you see, I also started counting from where it is minimum here. It gives us the list number on there. If I started counting from here, 1, 2, 3, my structure will be wrong. My structure will be wrong because now I'd find my what my double bond on carbon number 3 instead of carbon number 1. So hence it is now important to name starting from the what, from the functional group. Remember I said drawing the structure does not matter. As long as that structure I can convert it to the name that you were given, it's fine. Let's have another example. Now I'll combine a branch as well as a double bond so that you see which one you prioritize. I'll also make it interesting because we haven't dealt with something like this. Okay, it's fine. Remember, I want to try all possible things you might come across. Here, I do not say there is a missing hydrogen. No. Can you see on this carbon, the bonds, it is 1, 2, 3, 4. So there's nothing missing. If you put a hydrogen here, you are out. You are wrong. Okay. Make sure that as you do this, the number of carbons that you have are correct. Now let's look at the longest chain. The longest chain, I'll start looking, where is the functional group? Functional group, it is the double bond. Oh, here it is. So I'll start counting from the one that gives me the list number. Which one? I want to believe it is this side. Can you see it is 1, 2, 3, 4. When I go there, it is 5, 6. Okay. Could I have gone that way? If I have gone that way, it would have been 5. Can you see between 5 and 6? I want the longest chain. The chain I want the longest, but the functional group I want the minimum or the lowest. So I'm gonna say, okay, I go there. Okay, I go there. If I go there, it means I have this part. Okay, what happened to that one? I have this part that is not numbered, and that part we call it a what? A methyl group. Do you remember? This is methyl. Okay, and it is on carbon number, man. Can you see 1, 2, 3, 4? 4. Okay, on carbon number 4. Okay, yes. The question is, what if I started counting from here? If you start counting from here, it's going to be 1, 2. If you go down, it's going to be 3, 4. It is the lowest. Then I can say it is 2, 3, 4, 5. It still gives me the lowest. Can you see that? So hence I say, okay, let me start counting from this side. The way. But even if, can you see now, you give the what? The functional group, the biggest number. Instead of giving it 2, you give it 3. So we don't want that. We want you to give it the smallest number. So okay, that's the thing. Okay. Then we'll say, okay, when I name this, the longest chain, it is hex. The longest chain, it is hex 6, right? Hex. Then this is just me writing the longest chain. Then now I made okay, on that longest chain hex, I made a what? I made a methyl on carbon number 4. I'll say, okay, 4. On carbon number 4, I made a methyl. Then what else did I meet? I met on carbon number 2, I met a what? A functional group, which is an in. A functional group of alkane, which is in. I'll say, okay, on carbon number 2, I met an in. So how do I write this? Remember, hex and in will want to go like this. This will be hex to in. But now what will happen to the 4? 4 methyl. I'll say, okay, this is 4 methyl hex in. Okay, this is I. Okay, remember the longest chain and the functional group ends. Okay, they are at the end, whereas the branch is the one that is at the front. Okay, yes, the longest chain and the functional group, we end with them. Then here, I know I said this is a prefix. Okay, yes, it's still a prefix, but now can you see it is a prefix in terms of telling you the number of carbons? Okay, then here I have what? The number where I saw the branch. What if you named this hex or methyl 2 in? Read this. Does it make sense? Hex 4 methyl 2 in. Does it make sense? No. What makes sense is that it is 4 methyl hex 2 in. Okay, 4 methyl hex 2 in. What do I say it makes sense? Because now I'll be in a position of knowing how to draw the structure from what? From the given weight. The weight, it is what? 4 methyl hex 2 in. The important part when I draw, I want to check the functional group. It is what? Hex. So not the functional group, the longest chain, it is hex. I'll say 1, 2, 3, 4, 5, 6. Can you see? I'm just saying carbon, 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 carbon. Okay. Then I come here on position number 2, I find an in. Okay. When I start counting, I'll say it is 1, 2, 3, 4, 5, 6. It's fine. You can count from here. It's fine. Okay. It is 6. Then on carbon number mark 2, meaning I won't say between here. Why? Because if I say here, can you see it is between 1 and 2, and between 1 and 2, the smallest is what? It is 1. So, okay, it is not here, it's rather here. Between 2 and 3, between 2 and 3, which one is the smallest? It is 2. So it is there. Okay, then I do what? I complete the rest. I do not complete the rest with double bond. We do not have this. No. Hence, I want you to give me the position of the in of the double bond so that I know where to put the double bond. Okay, then I'll say, okay, here I'll have hydrogen, hydrogen, hydrogen. Here I'll have what? Hydrogen. Can I put hydrogen here? No. Why? Because it is 1, 2, 3, 4 already. Count the number of hydrogens you have on each, or number of bonds you have on each carbon. Okay. You miss one carbon, you lose 1 mark. You put an extra carbon, you lose 1 mark. That is the cruelty of IUPAC naming. Now, is it true? Can I name this? Oh, there is something that I forgot. Okay, I forgot. I just completed this, right? But I'm also told on carbon number 4, I have a methyl. So on carbon number 4, so I can come here and say, okay, let me remove 1 hydrogen and instead replace it with a what? With a methyl group. I can put it at the bottom or at the top, it's still fine. Okay, it's still fine. Now, is this the question will be but here the longest chain was something like that, Mus. Why is here the longest chain the straightest? Yes, when you draw, it's fine. When you draw, it's fine. You don't need to know the original structure was how. Okay, what you need to know, it is when you are given a name, you need to be in a position of drawing this name in a way such that I can be able to reverse it to the name you were given. Let's try that. Longest chain here, 1, 2, 3, 4, 5, 6, it is a hex. Then on carbon number 2, I met a what? An in, a double bond. I say on carbon number 2, I met an in. Then also what? On carbon number 4, on this one, I do not say it is between carbon number 3 and 4, then it is 3. I say on carbon number 4. Can you see? This is carbon number 4. Then it is a branch. It is directly on carbon number 4. Then I'll say, oh, on carbon number 4, I met a what? A methyl. Then the name here will be the same as that name here. It's fine. You are correct. You are indeed good. There is also a way to draw this. You can also draw this as maybe something like, see, I will ignore the hydrogens for now, okay? You can draw it like this. and say maybe 1, 2, 3, 4, 5, 6. You can also draw it like this. Okay. Can you see that? If you count here, remember you'll say, okay, I want the longest chain, 1, 2, 3, 4. Then I have to go up 5, 6. Then oh, meaning this is a branch. It's carbon number 4. It's fine. And another thing again, I need a double bond on carbon number 2. So I'll say, oh, a double bond on carbon number 2. Then it means I should remove 1, like that. Then you're in a position of is the same. Okay, yes. So now the drawing is not necessarily that important. I'll just show you how to know how to draw just basic structures that you can also be in a position of naming later on. Okay, now let's have one example under alkene. On this one, I'll have a branch that has, okay, something like 1, 2, 3, 4, 5 ish. What I want to do here, when I do this, 1, 2, 3, 4, 5, okay, let me just say 6. Oh, I've been reading rules here. This is enough. Okay. 1, 2, 3, 4. Oh, okay. I do not need to add extra. I add extra, I'm penalized. Also here, I'm wrong here. It is 1, 2, 3, 4. So I do not need that extra hydrogen. Okay. So it means I was going to get penalized also. But can you see the importance of counting now? It gives you an idea of whether you are breaching rules or not. Remember, when you give something to a name, you wouldn't agree. My name is Mpho Mutlung, okay? My name is Mpho Mutlung. But if someone would have said my name is Mutlung, Mutlu, this is not me. If they come to me and say, here is your name, here you are under arrested, I'll say, this is not me. I'm not Mutlung, I am Mpho with an H. So automatically, this is not me. It is wrong. Okay. Hence, the importance of naming. Or if they come and say, okay, let me do this. My original name and surname, it is Mpho Mtlung. But someone come and say your name is Mpho Mutlu. This is not me. This is not me. You have an extra H there. Maybe you're talking about Adam Mpho. So can you see now the importance of now being in a position of naming correctly, okay, and giving the correct bonds here, okay. Indeed, indeed, okay. Let's have that. Let's have that. Have that. Have that. Have that. All right. Okay. Here, 1, 2, 3. There is something short here. H. Okay. Good. Now, where do I start counting? I start counting from where I'll have the list number. Okay, where my functional group will have the list number, which is 1, 2, 3, 4, 5, 6. Can't need it. Okay. I did not want it like this, man. Ah. Uh, oh, okay. It's fine. 1, 2, 3, 4, 5, 6 again. If I went there, 5, 6. Can you see now it's the same? Sorry. Can you see now the longest chain is still the same? Whether I go this direction, still straight again, or whether I go that direction, okay, it's still the same. So what I'll do, I'll say, okay, I'll just prefer the longest, the straight chain is fine. I'll just go with the straight chain, meaning now this one will be a what? This whole part will be a branch. This whole part will be a what? A branch. But now I know a branch has only one carbon, yes. But this one, it is also a branch, but now it has how many carbons? 2. Remember, if it is a branch with one carbon, it is methyl. If it has 2 carbons, what does 2? What is the prefix of 2? It is eth, meaning it will be ethyl. Oh, this is how this thing works. Yes, indeed. This is how these things work. Okay, then I'll say it is 1, 2, 3, 4, 5, 6. Then on carbon number 4 I have an ethyl. So I'll say, okay, before I name I have an hex, the longest chain. Okay, but on that longest chain, what happened on that longest chain? I saw a functional group. Can need, yes, between carbon number 2 and 3. So which one gives me the minimum? It is 2. Okay, I'll say on the longest chain hex I saw on carbon number 2 of that hexane. Okay, so can you see, you should make sense of your naming. Is that okay? On my 6 carbons, which is hex, I met on my 6 carbons, which is hex, on carbon number 2 I met something special. What is that something special? Double bond. What is that double bond? Double bond, you call it in. Oh, interesting. But what is it that you also saw? I also saw on carbon number 4. Therefore, since well, this one is the ending, it means the other one will come here. On carbon number 4, I met what? I met an ethyl group. Oh, a branch, but now it has 2 carbons. We call it what? Ethyl. Oh, so interesting indeed. Yes, it is interesting, right? So here, there's no need for a space here. Like, it is just for ethyl. They can remember between a letter and a letter, between letters, there's no space or hyphen. Okay, you can just make space so that you can see what you have written, but okay. But can you see between a number and a letter, you have a hyphen. Between a number and a letter, you have a hyphen. Between a ganjalo ganjalo. Between two numbers, you have a comma, like that. Okay. Mm, mm, mm. Okay. Like that. What if now this one I will just do it from, I want from a part of it. Okay, let me see. Mhm. Okay, let's say I have this. Let's say I have that. If I have that, what is the longest chain? I start from here, where I have double bond. They say it is 1, 2, 3. When I go up, it is 4. When I come here, it is 4. When I come there, it is 4. So I'll prefer going with a straight line. So if it is 4, can you see I have a branch that is unnamed? A branch and a branch. So what do I call a branch and a branch? So do I call this eth? No. Why? Because here I have what? A branch here, which is 1 carbon, meaning this is eth. Sorry, this is methyl. This is also a methyl. Oh. So what do you mean in Pomanje? Because I have 2 methyls. If I have 2 methyls, can I not make them and say meth plus meth is eth? No, we don't do that. Instead, we're gonna say, okay, the longest chain, it is 1, 2, 3, 4, it is bute. Then on carbon number 2, here I met a functional group which is in. Okay. But instead, let me take this naming there. Okay. In, butene. Okay. But now I also saw something special, a branch and a branch. On carbon number 3, both of them were on carbon number 3. How can I do with that? I'm gonna say, okay, on carbon number 3 as well as carbon number 3, I met what? Can you see that? On carbon number 3 and carbon number 3, I met a what? Methyls. And they were single methyls, methyl number 1, methyl number 2. So I'm gonna say, oh, it means it is dimethyl. Oh, Taniti. Yes. So it means now when I draw this, I'll say 1, 2, 3, 4. Okay. Let me just say carbons like that. Then on carbon number 2, I have on carbon number 2, 1, 2. So this is carbon number 1, okay? Between 1 and 2. This is carbon number 1. Remember, functional group wants the smallest number. Between 1 and 2, the smallest number it is 1. So I'm going to say, oh, on carbon number 1, I have that. Okay, so it means this is that. This is that. Okay, then this is that. But now I'm not done. I'm done with this. But I'm also told on carbon number 3 and 3. What do I have? The methyl. Oh, it means on the first, when I start counting here, it's going to be 1, 2, 3, 4. So it means on carbon number 3 here, the first one, it is, I have that. On the second, okay. But what if I did this 3.3 dimethyl and said it is this? Is this correct? No. Why is it not correct? Because this on carbon number 3, it is no longer dimethyl. Remember, if I have a branch like that, this will be what? Will be eth. This will be ethyl. Oh, another thing. And if you check, if I were to draw it like that, can you see my longest chain will differ? Will be 1, 2, 3. Then this will be 4, will be 5. Oh, another thing. Another thing. Okay, can you see? It is no longer bute. It is now what? 5. 5, and it is what? Pent. Oh, so hence it is very important when you draw. You should after being given a what? A a function, okay, a name like this, and say give the draw the structure of this IUPAC name. Okay, draw the structure of that IUPAC name. You will draw it. After drawing it, try to name it again and see if you get the same number or the same name. If it is not the same name, it means it is incorrect. All right, yes, let's drink water. Water is very important, especially in these long lessons like these ones. Okay, now let's look at the last what last a compound under hydrocarbons. Already this video, it is long, so yes, we'll just break them into digestible lessons. Remember, I said so, right? So I'm gonna go to the last one, which is now alkene. So I'm done with alkene. I'm gonna go to alkanes, which is on number 3. Alkyne. Huh. That one was alkane. That one was alkene. This one was alkyne. Hey, but what is happening? Yes, this one is alkyne. This is homologous series. This is the homologous series, okay? This is the homologous series. Now, after homologous series, we'll be interested in what? In knowing the functional group. Can you guess the functional group? Let me give you an idea. We still have carbon and carbon. But remember, on alkane, we have carbon, carbon, single bond. Oh, okay. On alkene, we have carbon, carbon, double bond. Oh, okay. Is this what I'm thinking? Alkyne, is it carbon, carbon, triple bond? Indeed. Indeed. So it is carbon, carbon, triple bond. Oh, hey, chemistry is nice, Moose. Indeed. Chemistry is very interesting. I want to draw a precise thing here. Okay, meaning now I'll have only one bond left and one bond left. Ah, what do you mean? Because the other one we had like 2. Yes, why? Can you see when I count, it's going to be 1, 2, 3, then 4. So it is that 1, 2, 3, 4. Oh, okay. I get you now. Indeed. Indeed. Okay. So yes, it will be just that. Okay. So this is what makes it special. Yes, from the other homologous series. Yes, the functional group, it has 3 bonds. Okay, that's good. That's good. Now let's go to the general formula. Remember, I said as you move from alkane to alkene to alkyne, what do you do to the general formula? You subtract 2. Okay. On alkane, we had CnH2n plus 2. On alkene, we subtracted 2. It's gonna be CnH2n plus 0 when we subtract 2 again, which is just CnH2n. So it means when I go to alkyne rather, I'm gonna subtract 2. But where I'm gonna subtract 2 here. So it's gonna be 0. Here, remember, it is plus 0. 0 minus 2, it is minus 2. So okay. So the general formula for this one, it is what? CnH2n minus 2. Oh, not minus 2 like this. You are minusing 2 here. No. Yes. Okay. Yes. Now, the suffix. Can you guess it? Can you guess the suffix? I think you have already guessed the suffix. The suffix will be just "-ine". Okay. I don't know. Some people call it wine. Some people call it "-ine". I call it "-ine", alkyne. Okay. However you pronounce it. Okay. Now, okay. Let's be in a position of saying, okay. Let's now name, okay? Naming of alkynes. This is going to be simple because now we are going to follow the same structure as what? As the alkene now, okay? So I'll no longer give you basic things. I'll just straight away lahlela ntho tse enzima. Am I not breaking any rules? No. Okay. All right. Yes. Now, when I start counting, similarly to this one, you prioritize the functional group. Prioritize triple bond. Prioritize triple bond. Okay. Carbon, carbon, triple bond. So if they were to ask you, what is the functional group of alkynes? Alkynes, you're going to say it is carbon, carbon, triple bond. Or for alkenes, it is carbon, carbon, single bond. Or you're going to say carbon, carbon, single bond. Or for alkene, carbon, carbon, double bond. Oh. For alkynes, carbon, carbon, triple bond. Oh, hey, interesting. Okay, yes. So let's start counting. We start counting from where we have the smallest triple bond or functional group. 1, 2, 3, 4. Can you see if I were to go there, it's going to be 3. If I go there, it's going to be 3. So we don't want the smallest, longest chain. So we don't want the smallest chain. Hence, I prefer saying longest chain, not just the carbon chain, the longest carbon chain. All right, let's do that. So what will be this? This will be what? A branch. You all agree with me? This will also be a what? A branch. You all agree with me? Yes. Okay. Now, let's name that. When we name that, it's going to be what? 1, 2, 3, 4. We have bute. Okay. It is the longest chain. Now, on bute, we met a functional group. What kind of functional group? Alkyne. On carbon number 2, I met an alkyne. So a functional group of yne. I met a triple bond. Okay. I can say that I met a triple bond. Then here, what did I meet again? On carbon number 2 and carbon number 2, I met what? Methyl groups. So I'm going to say, oh, on carbon number 2 and carbon number 2, I met methyl groups. But since, well, there were 2 of them, I'm going to say it is dimethyl. Okay? You're going to have a maximum of trimethyl, but they really ask about tri. But you can have it. Okay? Okay, you can have it if, okay, let me do it like this. Let me do this. Let me change this name, actually. Yeah, I'm making it interesting now. Let's make the naming interesting. Okay. So similarly, it's still gonna be what? Let me write it here underneath because it's gonna be long. I still have what? 1, 2, 3, 4. Oh, okay. Now it will change to 1, 2, 3, 4, 5. Okay, I do not want that. Let me rather put it here. Okay, yes. So now can you see it's gonna be 1, 2, 3. If I go here, it is 4. Okay. If I come here, it is 4. Okay, it's fine. I'll continue with the straight chain. Okay. When you count, please consider all the options. When you go there, it is 3. Okay, it's little. When you go there, it is 3. Okay, 3. If I go there, 1, 2, 3, this is 4. So you have to check, compare which one gives you the longest chain. It is 1, 2, 1, 2, 3, 4, or going to that side 4. So instead, okay, I'll say, okay, let me remove this, remove this, remove this. I'll just continue with the straight long chain like that. Okay, so now when I name, I'll say, okay, the longest chain, it is what? Bute. I'm going to say bute. But on bute, I made the functional group on carbon number 1, carbon number 1. But remember, I said if it is between carbon number 2 and carbon number 1, the functional group, if it, remember, The functional group will take the minimum number, or rather the smallest number. Between 2 and 1, which one is the smallest? It is 1. So it will take 1 and say, okay, what kind of a functional group or special thing did you make? Triple bond. What do you call triple bond? You call it ine, like that, or wine. Okay. But okay, not only did I see ine on carbon number 1, but I also saw what? A branch on carbon number 2, a branch on carbon number 3, also a branch on carbon number, sorry, a branch on carbon number 2, also carbon number 2, carbon number 2, and carbon number 3. So how can I name this? Oh, this becomes tricky now. No, it is not. Trust me, it's not. What do you mean it's not when this name it becomes long? You're gonna say, okay, on carbon number 2, I met 2 methyls. Okay. You're gonna say on carbon number 2, I met a methyl. You're gonna consider all the methyls. On carbon number 2, I also met a methyl. On carbon number 3, I met a methyl again. So remember how do we add this? We're gonna say, okay, it is 2 comma 2 comma 3. Can you see? 2 comma 2 comma 3. Then how many methyls do I have? 1, 2, 3. Tri methyl. Ah, I get it now. Okay. So it means it's gonna be 2 comma 2 comma 3. This is not a hyphen, it is comma. Then a hyphen, it is between a number and a letter. Trimethyl butane. Okay. But 1 ine. Ha! Such a name. Okay. Yes. Now it makes me be in a position of saying, okay, I have an IUPAC name. Here it is. Let's say here this is an IUPAC name. Can I be in a position of throwing this? Yes. Why? Because I'll start here. I'll say but. But means for 1, 2, 3, 4. I don't know what for, okay? But I come here on carbon number 1, I have ine. Oh, so it means I have something special on carbon number 1. Let me start counting. I'll start counting here. That's fine. On carbon number 1, which is between 1 and 2, I have a what? A special thing, which is ine. I know ine, it is what? Triple bond. Oh, okay. Then it means now I can say this is one single. Then this one will just be left with that H. Okay. But okay, I'm only done with this part. I'm going to come in here. I have number 2, number 2, number 3. I have trimethyls. Okay. The tri tells you about how many a day. Okay. It is not important as of yet. Okay. Now I have what? A methyl on carbon number 1, number 2, number 2, number 3. I'm saying, oh, on carbon number 2, I have a methyl. Also on carbon number 2, I have a methyl. Oh, okay. So it will be wrong for me to say it is a methyl like this. Yes, because this no longer a meth, it is a eth. Oh, okay. Then also on carbon number 3. Oh, number 3. You have a what? A methyl again. Oh, okay. Then you can complete the rest. I see that. Can I put a hydrogen here? Yes. Why? Because the bonds here, it is what? 1, 2, 3, 4. Oh, okay. Here. Oh, okay. I violated the rules. I violated the rules. Okay. I cannot I cannot put a carbon here. Can you see? Check the number of bonds that I did. 1, 2, 3, 4, 5, 6. So what I have drawn here, it is very wrong. So the only thing that I could have drawn, maybe it is like that. Leading this carbon is gonna have 1, 2, 3, 4. It's wrong also, like that. But okay, now it's for the purpose of just explanation and what. So it's wrong, but it is wrong because now can you check the bond? 1, 2, 3, 4, 5, 6. Remember, carbon can only take how much? 4. Okay. So let's try a realistic one. Okay. Sorry about that. The last one that is realistic at least. Sorry. I got carried away. And yeah, I wanted to try something exciting. Okay. Yes. So let's try something exciting, but knowing that it is correct. Let's try something exciting, but now making sure that it is correct. Okay. Okay. 1, 2, 3. Okay. So it means this one, I need to leave it like that. Can you see why? Because check, on this carbon, it is 1, 2, 3, 4. Oh, so it means I do not need to include anything there. Oh, okay, can need it, yes. So this is very some of the important parts that are very, very important when naming. Or here I can say, oh, okay, can I do this? Oh, then it means this one I can do that. Oh, okay. Then that's cool then. Oh, on this one I can. Yes, you can. Oh, okay. That's interesting. Can you see I'm not violating any rules? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, sharp. Now I want you to make sure that each and every carbon is bonded to 4. Okay, not more than 4. So this is one of the very steps that you need to apply, okay, or know when you do what, when you draw. Now, remember, why am I avoiding to draw more carbons? Because A, they're gonna penalize me. Now, let's look. Where's my functional group? My functional group is the triple bond. So I'll start counting from where it is smallest. Can you see when I go there, it is 3. If I started the one, oh, if I go there, it is 3. Here, it is 4. Okay, if I go up instead of going down, it's going to be 4. Okay, if I continue straight, it's going to be 5, 4, 5. Okay, if I go up, it's going to be 6. If I go there, it's going to be 6. So can you see which one has the longest chain? 1, 2, 3, 4, 5, 6. Oh, so I can take this chain. Okay, or if I do not take that chain, I can take this chain. That is the longest one. Oh, okay, it's fine. But I prefer taking the what, the longest chain. If I do that, what should I do? I remove everything that does not fall under that line. Ah, okay, yes. So what does this become? Do you still remember? What does this become? This becomes our branch thereof. Oh, okay. Similarly, this, it does not fall on the longest chain, so it becomes our branch. Oh, okay. So we're gonna say, okay, when we name the longest chain, it is a hex. Longest chain, it is hex. Then on a hex, what is something special? Do we have a functional group? Yes. Here, triple bond on carbon number 1 between carbon 1 and carbon 2, which is carbon number 1. 1. What kind of a special thing do we meet there? We met iron. Oh, you can never encounter something like this where you have triple bond on two on multiple occasions, maybe here and maybe there. No, they'll make sure that you have it on only one carbon. Okay. Mhm. Okay. Now, okay, what did I meet again? On carbon number 3 and 3, I met a methyl, and carbon number 5, I met a methyl. Remember, I'll say, okay, 3, I have a methyl, 3, I have a methyl, 5, I had a methyl. Therefore, I have to combine this. It's going to give me what? 3.3.3 what? Trimethyl. Remember, between a number and a number, so 3.3.5. Between a number and a number, it is a comma or a dot, however. Then between a number and a letter, it is a hyphen. Okay. Between a letter and a letter, it is nothing. Okay. Can you see that? By looking at the structure, I should be in a position of knowing to take, I should be in a position of taking this structure and doing what? And drawing with it. Okay. So I'm gonna say, oh, okay. What do you mean? I mean the hex, it is 6, 1, 2, 3, 4, 5, 6. But now on carbon number 1, I have an iron. Okay. I can start counting here or from there, it's fine. So it means this is 1, 2, 3, 4, 5, 6. What else do I have? On carbon number 3, I have a methyl. Okay. Also on carbon number 3, I have a methyl. Oh, okay. How interesting. On carbon number 5, I have a methyl again. Oh, okay. It's all about methyls. Then I'm done. It's just a matter of completing all the other bonds. Okay. And you have to make sure that you do not violate any rules. Here it has 4, This one has 1, 2, 3, 4. Remember, if it is carbon like this, you check on this side, you check on this side the number of bonds. Okay, you also check at the top if they have in. So this is okay. Here, can you see on this carbon here? I have only one. On this carbon number 5, only one, 2. So it means I can complete the rest by saying, okay, it is 4, it is 5. You do not say it is 4, it is 5. You don't do that. Okay, like that. So is this the structure? Is the structure the same as that one? Let's try to do that. Yes, it is. Why? Because can you see here? I have a methyl group. I also had a methyl group there. And I also had a methyl group there. So can you see? Yes. So yes, that's all from me for hydrocarbons. Okay. So now let's move to the next video. I do not want to make a video that if I were to do only nomenclature on one video, it will take us 6 hours. Okay. So yes, let's just stop this video right here and join me on the next video where we'll be dealing with now alkane, alcohol as well as alcohol. Okay, yes. So now let's move to the next video. I'll just put the link on the description below so that you see. Okay, yes. Or you can just go under organic chemistry playlist. It will be in that particular order thereof. Okay. So yes, thank you very much. Let's meet on the next video. Thank you.